few of the more challenging problems here from your text. Let's start with page 73, number 45. You can see here in the textbook it says, graph the line that passes through the ordered pair 3, 3 and is perpendicular to the graph of y equals 3. Well, let's think for a moment here. If I want a line that's perpendicular to the graph of y equals 3, let's think about what we can gain from this. If it's perpendicular to this line, then it's going to have an opposite reciprocal slope. What type of line is y equals 3? Well, I know that y equals 3 is a horizontal line. It has a slope of 0. So the slope of a line that is perpendicular to this line is going to have an undefined slope. A line that's perpendicular to a horizontal line is going to have to be a vertical line that passes through this point. So if you recall from our last discussion, a vertical line is going to be written in the form of x equals some constant. Well, if I want it to pass through this point, what does x equal? 3. So let me graph the first line first that it's referring to here. I want it to be perpendicular to y equals 3. So the horizontal line of y equals 3. But I want it to pass through this point, 3, 3. So as you can see here, the vertical line that passes through there is perpendicular to it. And as discussed earlier, that vertical line will have an equation of x equals 3. One that's a little bit more challenging than that is problem number 50. As you can see, in problem number 50 asks you to graph a line that's perpendicular to another line and intersects it at its y-intercept. So what can we gain from this? We want to know the slope of this line as well as its y-intercept. So the easiest way to do that is to change this line into its slope-intercept form. I'm going to isolate the dependent variable y here by subtracting 2x from both sides first, leaving us with 5y equals negative 2x plus 10. Then dividing both sides by 5. And this line in slope-intercept form is then y equals negative 2/5 x plus 2. So I know now the slope of this line as well as the y-intercept. But I don't want to graph a line that's going to have the same slope. Rather, I want to graph a line that's perpendicular to it. So it has to have a slope that is the opposite reciprocal. The opposite reciprocal of negative 2/5 is a positive 5/2. And I want to have it intersect at the y-intercept, so it too is going to have a y-intercept of 2. So I'm really going to be graphing the line y equals 5/2 x plus 2. So let's graph that. Y equals 5/2 x plus 2. I'm going to start here. Let's grab a different color marker here. I'm going to start here at the y-intercept of 2. And remember that every point on that line is going to rise 5 and run 2. And I can go the opposite direction by going down 5 and to the left 2. Really, I only needed 2 points to determine this line, but I chose 3 because 3 is better than 2. And here you can see we have graphed the equation of the line y equals 5/2 x plus 2, which will be perpendicular to this line and cross at its y-intercept.
Brock Saunders, Bryce Ware.